Google's newest robot can unscrew a light bulb 92 times out of 100. Putting one back in, 36. That's not a leak. Google published both numbers itself. On July 30th, DeepMind shipped 3 robotics models at once. The headline was Whole Body Intelligence. Robots that walk, crouch, and reach at the same time. The demos are genuinely good. The appendix is more interesting. Because the tasks this robot fails at are the ones you'd hand a 10-year-old. Let's start with what actually shipped, because the announcement moved fast and most coverage stopped at the demo reel. 3 separate models, released on the same day, each doing a different job in the stack. The first is Gemini Robotics 2. It takes what the robot sees and what you tell it and turns that directly into motor control, feet to fingertips, in Google's phrasing. That phrase is doing a lot of work, and I'll come back to it. The second is ER2, the embodied reasoning model. This one is the planner sitting above the movement. It holds a task in its head for several minutes, across what Google describes as hundreds of individual decisions. It can also coordinate more than one robot at once, which is new. 2 machines, 1 plan. The third model runs entirely on the robot itself. No network, no cloud, nothing to phone home to. Keep that third one in your pocket. By the end of this, I think it's the only one that really matters. So, what does whole body intelligence actually mean, past the marketing? Last year's version only controlled the upper body, arms and hands, and nothing below that, which meant everything happened on a tabletop, because the robot physically could not go anywhere else. Now it plans from the torso down through the legs. It can twist, lean, drop to floor level, and stand back up while holding something. The testing was done on the Apptronik Apollo 2, a full-size humanoid using 2 different hand systems. 2 different hand systems were used, and the difference between them shows up all over the results. One of them, the Sharpa Wave, has 22 degrees of freedom. That is close to a human hand. With it, the robot was tested on knot tying and bag sealing. Genuinely hard, genuinely human tasks. That upgrade is real, and I don't want to undersell it. The workspace is no longer a table. It's a room. And on the industrial tasks, the numbers hold up well. Precise insertion, which means fitting a part into a slot with almost no tolerance for error. 89.6% on a Franca Duo with a standard gripper. Sorting a tray of unfamiliar tools into their correct slots came in at 78.9. Picking an object off a shelf at chest height, 76.3. Off a table, 68.4. For a general-purpose machine working in a cluttered space it has not memorized, those are serious results. And that is the version of this story most channels ran with last week. Nobody should wave that away, and I'm not going to. Then you get to the household tasks, and the floor falls out. Screwing a light bulb into a socket. 36%, 2 out of every 3 attempts fail. On a task most of us learned before we could read, sweeping debris into a dustpan. 32. Sealing a Ziploc bag. 40%. Tying a trash bag shut. 44. And simply picking something up off the floor, 45.7 against 68 on a table. Same robot, same week, same document. The only thing that changed was the room. It can seat a metal pin into a machined hole nearly 9 times out of 10. It cannot reliably sweep a floor. That gap is not a rounding error or a bad test day. That gap is the entire story. It also cuts straight through the pitch every humanoid company has been making for 2 years. The promise was always the home. Fold the laundry, load the dishwasher, tidy the room. These numbers say the home is the last room they'll get to, not the first. So why is a factory easier than a kitchen? It sounds backwards, because a factory is engineered, deliberately, to remove every surprise it possibly can. The part arrives in the same place, at the same angle, at the same moment, every single time. A jig holds it still. The lighting never changes. Nothing bends, nothing sags, nothing rolls away. A kitchen is the precise opposite of that, and it was never designed for a machine. A trash bag has no fixed shape at all. It changes form while you're holding it. A Ziploc seal needs even pressure along a line you can't actually see from both sides at once. A dustpan needs 2 hands doing 2 different jobs against a floor that pushes back unevenly. And a light bulb has to find a thread it cannot see, then turn without cross-threading it on the way in. which is exactly why you get 92 and 36 on the same object. Taking a bulb out only needs grip and rotation. The thread is already engaged for you. Putting one in needs alignment first, blind by feel, and alignment is the hard part. Roboticists have known this pattern for nearly 40 years. It has a name. The things humans find effortless are the things machines find hardest. Chess fell to a machine in 1997. Sweeping a floor still hasn't fallen. The reason is that evolution spent hundreds of millions of years on hands and balance. It spent about 5,000 on arithmetic. We built the machine for the easy half first. And Google says it outright in its own limitations section. Multi-fingered dexterous manipulation remains challenging. They also note the robots still need to get faster. That's a company documenting its own ceiling, which is rarer than it should be. Which brings us back to the third model, the one nobody put in a headline. It runs locally on the machine, with no connection required. Useful, but not remarkable on its own. The remarkable part is what it does when you put it in a body it has never seen. It adapts to unfamiliar robot hardware. Different joints, different limbs, different everything. In a few hours of adaptation, with fewer than 200 training examples. 200, not 2 million. That is a different order of problem, and it was demonstrated across several distinct platforms, not just the humanoid it was built on. That single detail matters more to me than any success rate on the entire list, because it means the intelligence stops being welded to one specific machine. Right now, every robotics company retrains its stack from scratch for every new chassis it builds. If that cost drops to an afternoon, the hardware stops being the moat. The expensive, slow part of robotics stops being the robot. There's a safety layer here too, and it deserves naming rather than skipping. Google built a benchmark that tests whether the robot refuses instructions it shouldn't follow, and whether it stops and asks a human when its own confidence drops too low. It can also detect a person nearby and trigger a safety stop mid-movement. A benchmark isn't a guarantee, but writing one down in public is how a company gets held to it later. So where does all of this actually leave us? The honest read is that this is a genuine step forward, pointed at the wrong room. Warehouses, assembly lines, tool handling. Those numbers are close to something you could deploy. Your house is nowhere near close, and the report says so in its own figures. Anyone selling you a home humanoid for next year is quietly selling you the 32%. The thing worth watching here isn't the humanoid at all. It's those 200 examples. When one brain can learn an unfamiliar body in an afternoon, the bottleneck moves somewhere else entirely. Google published its failures in the same document as its wins, at full resolution. Read the appendix, not the reel. The file isn't closed, it's just been marked, not yet.